All right, I'm getting the thumbs up from the back, so we'll get started here. Thanks for joining us. We're going to talk today about utilizing Standalone Cinder in hybrid OpenStack-non-OpenStack environments based on a proof of concept we did at Lenovo. That's kind of fun. Excited to share it with you. I am Jay Bryant. I've been in OpenStack since 2013, currently the Cinder PTL.
I'm Binjo, working with Lenovo in the Cloud Technology Center, and I work with OpenStack for 4 years already and contribute to OpenStack to several projects.
Rich Wellham. I've worked with OpenStack for a couple of years. I am a core in Cola, and I worked on Cola Kubernetes and OpenStack Helm.
Cool. So we had kind of the fun opportunity here to combine analytics, storage, containers, and we wanted to share that story with you here. And also, I don't know, you've probably been to other topics if you're into storage on Standalone Cinder. This is another example of kind of how we're taking Cinder beyond just the Nova OpenStack environment. So we were given the goal in this proof of concept. So a little bit of background is with Lenovo, we're trying to figure out how to get the company interested in cloud. They're interested in cloud, but how do we introduce OpenStack open source? And so one of the first POCs we did is this solution that we're presenting today. We wanted to address a problem that we were having with Lenovo is all of our storage solutions are from different vendors that we resell, and they may have different storage solutions all working in the same environment. Hard to get a single point of control to them. And also, a lot of them are VMware customers that have lived in the old ticketing version of I will get my storage through sending a request and some magic man does it and sends me the info. I'll go into this a little bit more here, but we wanted to get beyond that and use open source technology to do it. Obviously, as I mentioned, kind of a single pane of glass solution, and we wanted to use open technologies. In this case, we were able to leverage Cinder, Kubernetes, also then like Kafka and some Horizon technology in there as well. So what we came up with is we called it LUSAC, Lenovo Unified Storage and Analytics Controller. LUSAC's obviously easier to say than the mouthful, so we called it LUSAC. So what we're going to do is in the presentation, I'm going to go through the storage part. We're going to spend a little more time on that because as OpenStack users, that's probably going to be a little more familiar. As a guy who'd been working in OpenStack, I thought it was really cool, so I'm excited to share it. And then we'll go over the analytics piece of it and how it can tie in, followed by how we used containers and why. So, single pane of glass. We wanted to be able to migrate from either our existing storage platforms to newer versions or from third-party storage over to Lenovo storage. So that was one of the requirements. For some reason, our storage team thought it was crazy that we could do that. I'll show you it's not that crazy. We wanted to be able to integrate with pre-existing environments, which obviously OpenStack is good at, and so is Cinder. And we wanted to provide something that would integrate well with other software-defined storage solutions. We're looking at Ceph, obviously, as a solution to provide. And so obviously working with Cinder and the open source technologies met all of those needs. So what is the current user experience as we had seen it when we started this project? So you start out, the customer requests some storage, and I was baffled as an OpenStack guy. I just started with OpenStack, and so I always thought, well, I can go request my storage whenever I want. Then I got moved to a different team at IBM working with SoftLayer, and it's like, oh, I have to write a ticket to get storage? What? So there's a storage administrator sitting somewhere who would make some storage for me, for instance, out on my DS series storage, attach it to the compute, let me know that it's available, and then finally, I can start doing something with my storage. Normally that hopefully would only take, maybe a few hours, but maybe it'd take a few days. Can we make that more efficient? Yeah, I think we can, and that's where we brought LUSAC into play. It has a GUI interface for user interaction, you know, a nice friendly GUI interface. It's also got a CLI if you need it. Looks a lot like the Cinder CLI because, hey, it is. And it's got an API interface as well. So if you want to write applications to interface with this and do your storage provisioning and attachment, we can do that as well. So with that in place, we can send a request through any one of those three solutions. And obviously, in this case, we're going to start out on legacy storage, V-series we'll call legacy. It'll create that storage, and you can export it to your compute. Then obviously the user knows where that is now available and can go attach it to their compute and start using it from their instance for persistent volume storage. In the meantime, the administrator is happier because he's free to make sure the hardware is working. He's using the analytics aspect to see what kind of data is being used. Are we running out of storage? He's not busy doing, you know, the same commands over and over. We've automated the process. So here's the design we came up with. Sorry, it's a little bit of an eye chart, but it was to show all the possibilities that we could do by leveraging a solution like Cinder, where we've already got all the drivers written on the back end. Using Keystone, we're able to integrate with things like LDAP and Active Directory. We've got ways for, you know, the administrator, the self-service user, to interact with that Lenovo UI or a direct access API. We suggest that Swordfish might be a solution in the future, integration there. And then in this case, we focused on doing block storage, but obviously there's no reason that this couldn't become a more fully featured solution, including file and object storage management as well. So I'm going to run through a couple of demos. The first one shows administrative action interaction with the storage controller. So in this case, you know, instead of focusing on what the user can do, we'll look at what the storage administrator can do. So he starts out with storage sitting on a V-series system, exported to compute being used. It's VMware storage, or a VMware instance in this case. And he says, hey, I want to migrate to my new storage system. So he removes the export. He manages it in. So this, before this, was not managed by OpenStack at all. So he manages it into Cinder, moves it over to the new S-series storage, then exports it back to the compute, and it shows up again back to VMware, but now we have it managed in under the Cinder environment for use as part of that larger environment rather than being managed directly off the V-series storage where they don't, you know, the administrators don't want to give people access to that sort of thing, but they can take control through a storage controller like this and do it in a more user-friendly way. So here's an example of that actually happening using the POC we had. And I will make it full screen, and hopefully it's big enough that people can see it. So I started out with a disk mounted to a VMware instance here. I've got some data in it. I unmount it and disconnect it from that system. Currently living in a V-series, you may know it also as Storewise storage device. Now you can see I've disconnected it. It's no longer available there. Now I go over to the V-series interface and manually remove that export, unmap it. Yes, I really want to do this, as you always have to do. And now if we go back here and refresh, rescan the bus, we'll see that one of those disks disappears. It's no longer being exported out to the VMware system. And now we get to the fun part. I've got a clean Cinder instance running in the storage controller. And what I want to do is I want to go and manage that in. So I'm telling Cinder, hey, this storage is available to be managed by the Cinder instance. Unfortunately, I have to copy the volume name, but you know, in theory, this could all be also automated. This was a first stab at things. So we manage it in by telling it, first I'm going to show you here, we've got our service list, and what it does is it shows you we've got both a Lenovo B, which is the S-series storage, and then also the 3700, which is the V-series. So there I managed it in. I basically said, hey, I want to control that volume with our storage controller. And now at this point, I can take it and I can retype it from the GUI interface and move it over to the S-series storage. So this is an example of how an administrator could take existing storage that the controller knew nothing about it, manage it, and use it to move it around his data center. So I've got the 3700 type as well as the Lenovo B type there that you can see. And you can see the volume that I have pulled in there, J's demo vol. I managed it in. Now I'm going to retype it from being a V-series volume to a Lenovo S-series volume by changing the type. What happens on the back end at this point is so that we're compatible between different storage types is the Cinder host actually mounts up both volumes, creates a new one, mounts the existing one, moves the data over through the host controller. So it does require moving some data around, and if you're doing this a lot, you want to make sure that you have your Cinder instance running on a pretty, with a node with good I/O to do that. But now it's moved the data over to the Lenovo backend and removed it from the V-series storage. And at this point, I can now export it without having to go to the storage backend. Now, this is functionality we added into Horizon, the ability to manually export a volume without having to go through Nova. And it's code that we would like to work on getting upstreamed. But given a host name and an IP address and an IQN, you can set up the target to an initiator so that that storage is exported. Something that you can't, without the CLI right now, do with the Brick client. The Brick client will also only does it to a local host. This will allow you to do it to other backend compute nodes. So now I can see that I have successfully exported it to that, or I've made that target available. And now if we go back to the VMware instance and rescan the bus again, you'll see our disk pop back up down there. Ta-da. And now if we go back to my console, I've got to reattach it. So obviously, all of this we did manually. We didn't have the opportunity to automate this process, but you could obviously use, the VMware APIs to make this a bit more automated and scripted. And also then, if you had it running from your compute instance using APIs, you could do it all automated. So I make the disk available, and we say good. And now I go to the console, I hope, and you can see that we've got our storage back. Yeah, here we go. So SDB was gone. Now if I fdisk it again, we'll see that I've got storage there. I can mount it. Wouldn't have been fun if I did this live. I didn't have the guts. I didn't have the guts. I've seen too many demos go wrong. Plus, you'd have to watch me finger fumble and retry everything. There's my data. So I just took my data from one system to another, was able to migrate it, reconnect it, and put it in a new environment through our Lenovo Unified Storage Controller, storage and analytics controller, that would allow user management of it. Kind of interesting? Yay! Excellent. Thank you. I didn't expect that much enthusiasm, but I appreciate it, sir. Okay, so let's move on to the next step. So we also did this with a open source user interface. We're migrating to this really pretty looking one at the top. We did Horizon in the initial proof of concept. We're taking that technology and moving it to a new Lenovo Open Cloud offering that we're doing, but it'll offer all the same functionality here through the new interface. So here's what the new login looks like. So the idea is to be able to provide, not just for the end users, but also the administrators, a nice unified environment. Right now you have to go to, it might be the V-Series interface looks different from the S-Series because one's Seagate, one's IBM's technology. So we're trying to get to a point where you can say, hey, if I'm on a Lenovo storage environment, I'm going to see this. For the user, it should be their only point of contact to the storage, because obviously when we leverage things like Keystone, you now have user management put into the mix. Modular, which obviously Horizon is. And what did you do, Rich? Okay, so that was all the items there. So here's what one of the user interactions that I'll show looks like. You've got the user asking for a new volume, talks to the storage, it adds another volume. The volume that's there is obviously the one that we just moved over. It exports, it connects to storage, and ta-da, it looks good. This demo provides a little more of the, also the showing the user management aspect through, from the admin. I won't make you watch all of that because I assume all of you kind of know how Keystone does user management. We'll skip forward here to, so creating a project, and for user, so this is the LUSAC user project. All of the ability to do this stuff when we demoed to our storage BU, they were like, whoa, this is cool. And it's like, yeah, this is cloud. And setting up their access. So now we've got a user available there. And then it'll sign out from the administrator and switch over to being the actual user who wants to have some storage. It's nice and simple. I don't have steam coming out of my ears anymore. So no volumes to start with. So I'm able to create one, and I want to keep it, since our new storage environment is the S-Series, I'm going to use that type. Start from an empty volume, of course, the Lenovo type. Now, for those of you, I'm assuming you're all somewhat familiar with volume types, but as the administrator, I could have come in here and disabled access to the V-Series storage so that, as admin, I may be able to see both of them, but I don't want the user to create new volumes on there. And we also now have a spec in place right now to limit functionality. So you could leave the volume type there, but prevent users from actually doing creates on it. So that this would be an example of where you would use that, is where we're trying to migrate off to a new environment. So I just did the attachment through the GUI again. Again, this is function that we have. We're working on getting it upstreamed. I've had good support from the Cinder community because it fits very well with our standalone experience that we're moving towards for Cinder. And similar to the last one, we rescan the bus. Now we're going to have 6 disks out there instead of 5 that are available, or 6 LUNs. And we'll skip forward here to the more exciting part, since we've already seen the attachment. a raw disk device. So now the user obviously can go to their console. They're going to see a new disk attached at dev SDC that was not there previously. While we're watching this, how many of you guys have hybrid cloud environments where you have OpenStack and VMware running together, or OpenStack and something else? Is this interesting? Okay, good. I like to see the head nodding, and people are listening. That's a bonus too. So obviously here now we're formatting or creating our file system after partitioning it. And that all happens nice and quick on the storage. And then we can mount it. I can show you that it's mounted and that it's all proper, just in case you didn't believe me here. This was big enough everybody could see it. Yeah, good. I was a little worried when I was in here earlier, and I'm like, that's a big screen. I think we'll be okay. So I'm able to write to that disk, and then now obviously I could take that and move that to, I could boot it up on an OpenStack backed instance, use it in another VMware backed instance. All good there. Cool? Is that interesting? I liked it. So integration with other environments, that's what we're kind of trying to get to here. You got a storage controller, you got some storage, and then we're making it possible to do data path access from whether it's Azure, OpenStack, VMware, some other legacy cloud solution. We can do this, and we can do it with open source technologies. We are able to do it in what, 6 weeks time? This was something our storage BU had been looking, and customers have been saying, well, why can't we do this? And I said, well, it's too expensive and takes too long. And we literally, in about 6 weeks, were able to get it done. So open technologies make stuff like this possible, and it's easier. So now that we've done that, you got to know what you're doing with your storage. And that's where this fine man comes along.
Thank you.
To tell you more about that.
So in the part of the LUSAC project, we not only extend the function of user experience across different storage backend, we also trying to improve the operational experience because each backend storage may have different operational interface. For example, PM data may be different, how people pulling logs method may be different. If you expect end user to know using different hardware, just using different method to pulling out to use the PM data, then it's really a nightmare. So we want to unify that experience also by basically building a data pipeline and collect all the information we want, for example, logs, metrics, and present in a unified interface to allow operator to see the problem and even apply AI and machine learning to do some interesting stuff. So I mainly introduce the work we're doing on this area. So why and what data we collect from the storage system? The reason we want doing this is, first of all, is to reduce the disruption and downtime, because the virtual infrastructure is really complex. And when problems happen, it takes lots of effort to do troubleshooting, to really do a root cause analysis to find out what's the root cause. And so we want to do it, provide all the information to the user in a centralized way, so user can really easy to see how to correlate the event, how to correlate the log to see easily to see what's the root cause. And we also, as another topic is about performance. For the performance, we want to monitor runtime performance. We want even find the opportunity to tune the performance, to diagnose performance issue between the storage or for example, another way is networking. My networking is not good enough for the storage. Without correlation, it's difficult to say. And another advantage of collecting the data from the end system is we have the opportunity to really use the data to predict, to proactively doing something instead of waiting bad thing happen and correct it. And correlate the performance between, we can correlate performance between across the host, networking, and storage. That means different components in the system, so we can get the whole picture of the system. And unified interface is another thing. So this is so the data side. We want logs, we want performance metrics, we want the configuration of the software and hardware, and we want alarms and events generated from the system. So what we do really first thing is we actually need to build this data pipeline. If you look at it, I want to say it's a 3-step. First step is we want to collect information from these 5 layers: hardware, OS, operating system, hypervisor, VMs, and application. By application, I mean the software, and also it's possible it's containers running within the VMs. And by collecting this information, we want to aggregate those information and send it to a cloud. We call it data analytic cloud. So within data analytic cloud, we have opportunity to analyze the data. And the challenge for that is it has to be highly scalable, because we are talking about monitoring thousands of systems so it's every component of this data pipeline have to be scalable, and it's need to highly available. Something goes wrong, we don't want the system to get down, and easily maintainable. So it's also need to expandable, because lots of cases we get new hardware, we don't need to rewrite software to adapt to this new hardware, right? So then basically this is the design for collecting data from the system. We use all the software we use are open source. So if you look at it, we use this for logs, we use Filebit. For other data, we can use Telegraph. Telegraph is very extendable to collect lots of metric information, for example, bandwidth or throughput, or even storage usage, CPU usage, so those kind of things. Filebit we use to collect logs. We also use actually rsyslog for our backend storage. We use rsyslog. And the design can be agentless or agent-based. In this solution, we prefer agent-based because it's easily to extend to new hardware, because the only change will be on the agent side. We don't need to change the infrastructure side. And we also have opportunity to do traffic throttle, because the information we collect may be massive information, but if there's nothing wrong, probably we don't have to collect all the information. We can just collect select information. So That's something we do on the agent side. So all the information we collect, we can send to a pipeline next step we call data aggregator through a standard protocol. Here, this left side is basically showing the data aggregator. If you see each component, the green part shows the infrastructure related components. The blue color one basically shows the components we use for monitoring for the data pipeline, for basically to collect the data. This is really built based on Kubernetes technology, so Rich will have more detail on that. But basically, we collect the information from all the components. We stream them out. We have our data collection, like telegraph there. We have telegraph. We have FluentD building the data aggregator, and that information sent to a pipeline using Kafka. And through Kafka, it's sent to our data analytic cloud. For data analytic cloud, we basically choose this IUDP, is a Lenovo unified data platform. It's you can say it's deployed globally, and it's I think that's the right platform for us. But obviously, user can choose other public cloud, even public cloud, to do this, use as this centralized analytic cloud. So the function within the centralized analytic cloud mainly to aggregate all the data in the database and make it available for data analytic engine to analyze the data. So for logs and for metrics, we use the data in our design goes to different paths. The logs data we basically using ELK to handle it because it's mature technology. For metrics, we use telegraph and promises. So it's not like it's basically combined with two different stacks, but we make it work and make data available to our UI. So the UI right now is not fully integrated like between logs and metrics. For metrics, we're mainly using Grafana, and for logs, we use Kibana. But basically, the logs from different hardware, different component is all available in Kibana and all indexed and tagged properly. So user can easily, whatever user can, I don't know if people here have a good experience with ELK, so people can fully use that ability to cross-reference of logs to look at, to zoom down and do the analytic to find a problem. And we make this data available to our own developed, we call it analytic engine. Basically, it's running on a big data platform, which provided by RUDP already. So we use Spark and HDFS underneath. But the analytic engine is, because we have all the data available, so we do have the opportunity to look at the data, to get more information from the data. So one thing, one demo we did in this project is to predict the storage usage. So from Cinder, we can have a log saying, how much storage being allocated. But that data basically is in logs. We can abstract those data and send out to the analytic engine. Analytic engine have this data, and using algorithm here, we use a machine learning algorithm to find out the training of the usage data, and give alarm. Basically, it's not only saying, okay, so you reach 90% threshold, but also saying you will reach 95% threshold in 5 days, for example, based on your existing usage pattern. So this is one advantage, to have all the data together and doing some interesting stuff. So this part, right now, we are still in a very, very early age to develop some feature, but in the future, because we have the data, it's, the potential opportunity is endless. And I have a summary of what we did here. So basically, in the demo, in the POC, we have 3 distributed locations. We have this. We have the system we run at Shanghai, China, and we have another cloud running on RTP states. And we collect data, send that data actually to Tianjin, China. So it's 3 distributed locations, and we collect data from all the 5 layers of our infrastructure. There are lots of open source components in the pipeline, and lots of components we collect. We collect networking, storage, CPU, memory, and different software too. So if you look, I didn't go through the scalable part. We actually, by selecting the components, we make sure it's scalable, it's cloud native, and we do so we have lots of thoughts on that side also. Resilient, same way. So basically, that's a summary. So we want to unify the experience of operational experience and give also a unified kind of interface for user to operate the storage or even different cloud. So that's from me. So.
Cool. Okay, so I have about 2 minutes to do infrastructure. That's typical, isn't it? So when the team, excuse me, came to me to ask to build the infrastructure for this proof of concept, I wanted to build something that wouldn't be defunct 2 months later. And so we sat down and we wrote, what exactly do we want to do here? What are our objectives? And so we wanted something based on stable controlled source code. It should be quick and easy to deploy and redeploy. It should encompass a development environment, because this was a development project as well as a production project. We wanted the CI/CD. We wanted isolation of technologies, because we had multiple different teams working on multiple different pieces of this design, and we didn't want to step on each other's toes. It had to be future-proof. We wanted cutting edge simply because that's what makes it future-proof and looks good. So forward-looking all the way with some operational ease, and then it needed to be resilient, it needed to scale, and it needed to scale out when we wanted to add new features. And whatever we did, we wanted to push it back upstream, of course, because that was the whole purpose of using open source software in the first place. So the solution we came up with was obviously a containerized infrastructure with microservice adoption and all running on a Kubernetes cluster. So again, most of this is not new to anyone, I'm sure. Why are organizations moving to microservices? Well, they provide the isolation. There's a very quick ramp up for developers because you can typically focus on your piece or your container environment and not have to worry about what everyone else is doing. It's not monolithic. I wanted the upgrade capability, and we used that quite a lot in the 6-7 weeks that we were working on this. Obviously, it accelerates rollouts, and microservices leads to containerization. I'm not going to explain what microservices are in any great detail. If anyone wants to take a picture, this is my concept of it. But again, it's nothing too new here. So yes, I did draw this slide. It's not great. So this is kind of how I feel about Docker. It's a great concept, and you push it up a hill, and you containerize and microservice your application. And then someone says, well, what about everything else that brings you into providing a production-ready environment, right? What about security, code quality, container hosting, peer discovery, scale, and so on and so on. And the speed at which Docker took over was insane, and then people developed things and then were left with this big mess. And so, of course, container orchestration engines came into the picture, and again, I'm not telling anyone anything that they don't know. Kubernetes is the red hot technology. So just to kind of explain why I went with this environment, yeah, it's the open source standard right now. It's developed at a really grand scale, so it can run on a VM all the way across the planet. We know it's developed by Google. It is the single fastest growing open source software solution currently. A lot of people have committed to it, right? And this is just a quick query that I did, and you can see that the increase of jobs and queries and so on is just gone insane. So really I wasn't going to fight and swim against the stream, so I went with a Kubernetes deployment. So this is what I did, and again, nothing too new here. So there's the develop side of things. So we were using and reusing certain components of the open source and particular OpenStack community. So you saw from the earlier demo that our Horizon has a pretty Lenovo logo and has some very specific feature additions that we're going to push upstream. And then there was some Cinder pieces and lots of other little pieces. So this was kind of our develop pipeline, if you like. And so how did I do it? Well, I used Cola. Hopefully everyone's been to a Cola presentation, at least in this summit. And if you haven't, I recommend going out and looking at it. Cola, there's always a little bit of confusion around it because it's also deployment technology as well. But Cola itself is simply a set of tools to allow you to build Docker containers. And you're actually building Docker images and you're deploying containers. So what I was able to do was, for the elements of the open source that we were making changes to, I can point Cola build tools to those particular elements, and the rest of it I get free from the community. So the pieces of OpenStack that we're not touching, I don't touch. I just pull those Docker images straight from Docker and run it that way. And so on the left side, our team that was working on Horizon changes would make changes, and when they would commit them, CI/CD would pick that up, would generate the images, would push them out to a Docker registry. Again, nothing new. The only thing is I was combining our elements of change with the rest of the very stable OpenStack images. And so basically, then I deployed it. And as a second slide, if you look at the middle column and the right column, it's really our CI/CD. And so the demos that Jay showed you, everything that Ben showed you, was all running on this infrastructure, running on a Kubernetes cluster. And there's a little bit of a lie or a deception here. I don't know. The deployment with OpenStack Helm. So I actually built this on Cola Kubernetes, which we have sunsetted. And so the second round of this is deploying it OpenStack Helm. But again, if you haven't checked out this technology, it's pretty amazing. But it allows you to run OpenStack directly using Cola containers. And so that's what we did. So all of the advantages that you get from running on a Kubernetes cluster was presented to us in this solution. All right.
All right, so I'll go quick. I'm sorry we've run over. So what did we learn? We learned open technologies can be leveraged to solve real-world problems. That was good. It reduces our internal development burden, provides a richer solution with less work required, and it speeds our time to market, obviously, being able to do something that for years had been avoided because it took too much resource. We did in weeks. Best-in-class solutions, because we've got you people helping us out, providing the technology. We can improve existing storage and virtualization experience. We're looking forward to do that as Lenovo continues to become part of the OpenStack community. We can use open solutions to get big data analytics in play. And you know, we can definitely use open technologies to improve the user and administrative experience, and we're very pleased with our ability to do that in this demo. So we don't really have time for questions. Catch us afterwards if you'd like to ask anything. Otherwise, thank you very much for your attention, and have a good rest of the summit.